Exercise 109. So we have constructed this map theta, and last exercise we have proved that this theta is open map of topological space, and it is also WK bar linear map of WK bar algebra. Yeah. So now we have also constructed a map C of the form omega 1 0 0 as element in WR, where this is element of R, such that it starts with minus P, and then of course P through to minus P, etc. And we have checked that theta of this omega plus P this is that forms why this P is then, this P is P times 1, which is P times 1 0, which is Frobenius Woshibon Frobenius. So this is apply Frobenius and Woshibon, then this is shifting and raising to the P's power, which is again itself. And so here we are saying that this is actually it's not easy to compute addition and multiplication in WR, but in this special case there are many zeros, and this should be easy, and this should be this one. But I'm not using any general formula, it just should comes from the first few terms of the formal group law for this addition. Notice that theta of C is 0 because this is by formula of theta. Omega 0 times P times P times 1 1. So this is minus P plus P, because 1 1 is again P. 1 1 is again 1, because 1 should correspond to weight. exactly. So this 1 of WR is 1, 0, but this 1 of R corresponds to 1, then pth root 1, and so this is 1R1. This is P. Okay, so this is in the kernel. Now we're going to prove more delicate or more detailed structure of kernel theta. First exercise, kernel theta is principal, ideal, and hence it is generated by C. So we take any element from kernel theta if we write x equals cy0 plus p times x1 for some sense, if we could write x equals cy0 plus px1 for some I0 x1 WR, for example, this is the case if kernel theta could be generated by P and C, right? Then we notice that theta of x equals P times theta of x1, because theta of c equals 0, theta is a ring map. Theta of x is P theta x. And so this must be 0 because x is in the kernel. But everything is now happening in the target of theta, which is OCK. This is p torsion free. Hence, this implies that theta x1 must be 0. In other words, x1 is in the kernel of theta. This is under the assumption we could write it in this form. So, if we could prove kernel of theta equals P, the ideal generated by P and C, then actually we can conclude kernel of theta equals the ideal generated by C. Why? Because, just repeat the procedure. So if that is the case, the assumption, let's put a star here. So star implies any x in kernel theta, x is cy0 plus p x1 for some x1 in kernel theta, and then this is again cy0 plus p times something in kernel theta is then cy1 plus p times some x2 with this x2 in kernel theta, and then iteration. This is a continue cy0 plus p cy1 plus p squared times x2 could be written as cy2 plus px3. So this is cy0 plus p y1 plus p square y squared plus p cube x3, as you could observe by induction passing to the limit. This would tell you, because this is ck is complete for the valuation topology, in particular for the p-adic topology. So finally this is telling you that x is actually c y0 plus p y1 plus p squared plus etc. And this is element lies in obviously OCK, because this is complete valuation. And so this is in the ideal generated like c squared. So we're left to prove that. Now assume x is x0, x1 is in kernel of theta, then 0 is theta of x equals, by formula of theta, x00 plus p x11 plus etc. equals p times summation and is bigger than 0 p n minus 1 x n n. So the valuation of this is infinity. The valuation of this is bigger or equal than 1, and so this implies the valuation of this should be, it cannot be smaller than 1, otherwise this is the minimum one and the valuation should be that one, but the valuation is infinity, so the valuation again should be bigger or equal than 1. So valuation of x0, 0 is bigger or equal than 1, equal to VPP. This also implies that Vx0 is bigger or equal to 1, because by definition this valuation of x0 is the valuation on its first component as the valuation on R. There is a valuation on WR. The valuation. Here's valuation on R, and there is valuation on WOK or WCK. OK bar or WCK. Yes. Put WR, WCK or WCK just. Good. And so what the valuation of omega, because omega 0 is minus p. Therefore, there exists some element of R such that x equals this element times omega. So x is in R, omega bar is in R, so this is in R. Because x has valuation bigger or equal than the valuation of omega. And in fractional R, you can always find such b0, but because the valuation of this b0 must be positive, so this b0 is again in R. Now let E tangentially lift to b0, so this is in W of R now. Then let's consider x minus b c. This is, so those are elements in WR. So x0 minus p0 this is b tangent relative to b0 times c. C is omega 1 0 by our construction. Then this would be x0 x1 again minus here b0 of omega bar b0 to the power p times 1 and 0 square. This is again using the formula for addition or multiplication in between, which is power series on each component. Finally, what did we get? This is x0 minus p0 omega for the first component, and then some y1, y2, let's don't care. And then this equals zero because x equals b0 omega. X equals b0 omega. And so x0 equals b0 omega. Wait. So this p0 omega, this omega is in so omega is in R, p0 is in R, this equals x is in R, and what is x? X here is assumed to be the kernel, containing kernel of theta, so this is element in W of R. X is in W of R. So here is just small mistake. Here is S0 because as we say, it's the valuation of x0 that is equal to the valuation of omega bar right in R. X is in W bar, x0 is in R. This is in W bar, so this is x0. Now we see this is 0, and then we don't care. And so this is P times some element because the major multiplication might be is exactly shifting the position, make the first component 0. So what have we proved? For any element in the kernel up to minus by some element, the principal idea of C, we left with element divisible by P. And here yi prime to the power P obviously equals yi. And so as we have proved, the kernel theta is contained in ideal generated by C and P, and hence it is by our argument the ideal generated by C. And we are done.